do we need to let you share your screen?
Yeah, you do.
Okay, I think, here, are you the,
I hit screen sharing and it says the host is disabled, participant screen sharing.
let's see, I think hopefully Kira can.
I'm working on it. Hold on. Okay, give that a try.
Dr. Jones, I think you can try now.
All right, that looks good there.
Okay, great. Well, thanks for inviting me. Again, my name's Chris Jones. I'm my title's research engineer. I'm probably the only guy. Well, I'm sure you know this. Lots of engineers call themselves scientists, but not many scientists call themselves engineers. So I'm the only guy in Iowa, the only chemist in Iowa that can call himself an engineer. But anyway, I work out of IIHR, Hydroscience and Engineering, and we're located on this building here on the river, just downstream from the Burlington Street Bridge. And IIHR, the Institute, has been on campus for exactly 100 years. There's been quite a lot of research done over the decades here on ship hydrodynamics, dam design, flooding, hydraulics, and some other things. And in recent years, the Institute has gotten involved in water quality. And so that's where my focus is. My office is actually located in Trowbridge. I'm not in here. I work closely with Keith Schilling, who's the state geologist for the Iowa Geological Survey, and they're in Trowbridge, and so I'm over there. And so I do have an active website, and I post all my presentations. Sometimes it can take me a few days to get them on there, but if you want my slides, you're welcome to go on there and get them. As Riley mentioned, I do have a blog, and I try to post stuff fairly regularly. And if you're interested in Iowa and Iowa water quality and how it relates to agriculture and land use and geology and a lot of other things, you might go to the blog and check it out. And so the main function of my job is to manage the university's network of water quality sensors. This is one of the sites. I believe this is on Clear Creek here, just west of town. There's about 70 sites throughout the state of Iowa where you can go and you can see what water quality is in real time. We're measuring nitrate at all the sites, and we measure these other parameters, a subset at a subset of sites. And so this is a site on the Wapsipinicon River near DeWitt, Iowa. And the sensors slide down through that PVC pipe that you see on the left there into the moving river water. Then up on the riverbank, we have a dry box with a solar panel, a deep cycle battery, a modem, and a data logger that sends the data back to the university in 15-minute packets. Here's another site. This is at a constructed wetland in northeast Iowa, where we're measuring water quality going into the wetland and water quality leaving the wetland. And we've had some grad students study that. We had one guy get his PhD evaluating the capacity of this wetland to sequester nutrients and keep it out of the stream network. And so there's an excellent website here, and I'd invite you to go and take a look at this, the Iowa Water Quality Information System, that makes the data accessible to the public. And so you click on a spot and it'll delineate the watershed area upstream from the site, and it'll give you the water quality data in real time. There's also an excellent land use tool on the website, and you can click on spot in Iowa. It'll delineate the upstream watershed area and tell you what the land cover is in that watershed. And so this is the Iowa River upstream of Iowa City, and you can see there corn 38%, soybeans 29%, and so forth. So I do try to publish original research using the data. And again, I work closely with Keith Schilling, and see, these are some of the topics that we've been able to publish papers on in the last 5 years or so. And so whenever I give talks, I try to impress upon people that to understand Iowa and water quality and flooding in Iowa, we need to also understand the geological history of Iowa. And of course, that's one of glaciation. And so we think glaciers have intruded into Iowa 7 times, but there's been 3 main events. And the first one is what we call the Illinoisan or the pre-Illinoisan event, where ice extended down to the current course of the Missouri River down in central Missouri there. Covered pretty much all of the state or close to all of it. Maybe northeast Iowa did not get ice, but most of Iowa was covered by this sheet. And so then we have the Illinoisan period where ice just sort of edged into the southeastern portion of Iowa. And you can see evidence of this here in Iowa City. You see it's very hilly in town here, but you go south of town and it gets really flat in a hurry. And that's where the edge of that glacier intruded into southeast Iowa. And then finally, we have the Wisconsin Glacier, which is the one we talk about the most. This tongue of ice extended into north central Iowa. And that created what we call the Des Moines Lobe. And so that is important when we talk about the changes in hydrology that have occurred since European settlement. And along with that, the water quality changes. And so Iowa has several different landforms. You can see them there. Southern Iowa drift plains, what a lot of people think about in Iowa as they drive across Interstate 80, the rolling hills. And then we have the Prairie Pothole area where the Des Moines Lobe was. The Iowan surface and the northwest Iowa plains were tundra when the Wisconsin Glacier was here. We have the Paleozoic Plateau in far northeast Iowa that, maybe did not have any glaciation, and then these other smaller areas. And so it's important to recognize that when we talk about agriculture and water quality here in Iowa, that we have some of the most extreme climate on earth here in this Prairie Pothole region that extends from Des Moines up to about Edmonton, Alberta. We have literature that says this is the most extreme and dynamic climate on earth. And so, some years we can get 10 inches of rain, some years we can get 60 inches of rain. And especially our winters can be highly variable. We can have a winter like northern Minnesota, or we can have a winter like St. Louis. And so this all affects how we try to design our systems in ways that enhance environmental outcomes. And of course, prior to settlement, this is what Iowa looked like. The top there, the Prairie Pothole wetlands. The bottom left, the oak savanna, which is kind of a mixture of these oak trees and tall grass prairie. And then the lower right there, the tall grass prairie. And of course, all this is gone for the most part, all been transformed to agriculture. And so the brown areas that we see in this map are now crops. And so about 70% of Iowa is now cropped to corn and soybean. We still have some forest left. We probably have not lost a lot of forest in total, mainly because our forest was in areas that weren't very farmable. And so when you look at streams in Iowa, you go and you drive across the countryside and you see a stream down there, and you might think that's the way it should look, as you drive across a bridge. Well, it's not. prior to European settlement, our prairie streams were shallow and wide, and they spilled out onto the floodplain very regularly. We had perennial vegetation on the riverbanks. We had gently sloping banks, and the water table was very close to the surface of the land. And so the assembly of fish species that we would have had the clean water species like smallmouth bass and pumpkin seed sunfish, and then generalist species like the channel catfish. And this was how water would move, exchange between the stream and the ground prior to settlement. Very little surface runoff. The prairie plants created surface area for water to be absorbed. Very little seepage in through the bank, and a lot of groundwater interaction. And then we got here, we wanted to farm it, of course, and so that meant draining a lot of it. And so we use these big steam shovels to create these trapezoidal ditches, especially in the northern 2/3 of the state. We installed the field tiles. These guys in the lower left over by Ames, those sections were installed with gaps in between them, so water could collect in the pipe and then drain out to these trapezoidal ditches. And so this greatly modified the hydrology of Iowa and changed everything essentially. And so here's a picture of some tile getting ready to be installed, new tile. It's now the corrugated plastic pipe. And so these blue areas are areas of Iowa where we know for certain there's tile. Actually, this is probably a vast underestimate for the southern part of the state. So now our streams start like this, right? So we have these big county tile mains that collect the water from the field tiles. And this is how our streams begin. And so this is the start of the Raccoon River in northwest Iowa. And so instead of these streams sort of spilling out of wetlands in a real gentle way, we can see that, they begin at a pipe. And so this is the headwaters of the Iowa River in north central Iowa, another example. And so our streams, they begin as tiles, right? And so that's greatly modified the hydrology of the state. And we get an immediate drop at the tile outlet of about 1.4 meters on average across Iowa. And so that water has energy just immediately as it leaves the field. And we contrast that to the wetland sources that were here prior to settlement. And so we've energized the water. And so now our streams are down in these canyons. And so you drive across Iowa and you go across a bridge and you see the stream way down there, right? And so that's not the way it was. That's not the natural condition. And so we've replaced the perennial vegetation with the annual plants of corn and soybean. And so now our streams are deep and narrow. We have all this, these banks that are unvegetated and they're very, very vulnerable. The streams come up very rapidly. They access that soil along the riverbank and cause our streams to be muddier than what they should be. And then the materials at the bottom, the sands and gravels, have been silted in. And so now we have these pollution tolerant species like the carp and the bullhead, and we still have some generalist species with channel catfish. And so the way water moves in and out of the streams has been totally transformed. We have the tile drainage. We have a lot more surface runoff and a lot more seepage into the stream. And so when we look at how drainage has transformed Iowa, this is Bear Creek in central Iowa, and on the far left there, the red are the stream that was there in 1847. The middle one is the stream in 1919, and on the right is the streams in 1972. And so we've extended the streams up into the watershed with the drainage and the draining of the wetlands. A little bit about Walnut Creek in Jasper County. The red there is the pre-settlement stream. The blue is the present stream. And so we've straightened the main branch of Walnut Creek and then extended these ditches up into the watershed. And so now, since we've straightened these streams, the water has a lot more energy. And so the drop from A to B is still the same now as it was in 1930. But the stream has been shortened by 500 meters. And so consequently, that water going down that stream has much more energy, right? And because it's not meandering throughout the floodplain. And so this has consequences for everything: flooding, erosion, nutrient loss, and so forth. At the same time, we've been doing all this, things have been getting wetter across Iowa. These are our 9 crop districts, and you can see how much precipitation has changed over the last century. Raccoon River, where I do a lot of my work, you can see this trend in precipitation. And so this has been manifested in increased stream flow. This is the Wapsipinicon River here in eastern Iowa. And especially in base flow. And so base flow is a portion of the total flow that occurs between storm events. And so we really move the water off the landscape very rapidly. Same with the Nishnabotna, the Des Moines River, the Iowa River, Marengo. And so this is only going to get worse. We know that with climate change, we're going to increase precipitation. We see here Perry, Iowa, projection at 24 to 32% increase in precipitation over the next 30, 40 years or so. Farmers will respond to this by putting in more tile. And so this is a sort of a classic spiral, if you will. More rain, more tile, more river flows, more pollution. And so as an example here, Winneshiek County, Northeast Iowa, we can see how the crop area has increased since 1980. That means we've put down more nitrogen, commercial fertilizer. And then we look at how the water quality has responded. And so each of these lines is a plot of the nitrate load in the stream versus the discharge. We can see this as we divide it into decades. The response of stream nitrate to discharges is increasing, right? And so not only are flows increasing, but the amount of nitrogen per unit flow is increasing. And so this has consequences across Iowa, but also areas distant from Iowa. We have the Gulf of Mexico there in the lower right. The nutrients from the Corn Belt enter the Mississippi and are discharged into the Gulf. We get these big algae blooms down there. The algae bloom, and when they die, they consume oxygen, and then that leaves the estuary unsuitable for a lot of the aquatic life that we associate with the area. And so this affects commercial fishing and biodiversity and all sorts of other things down there. We also have an issue with Lake Erie, which is on the left there. Western Ohio and eastern Indiana are much like Iowa, very high intensity of tile drainage, a lot of livestock, corn and soybeans. And so these nutrients enter the streams in that region and cause these similar algae blooms in Lake Erie. And so this has had consequences not just for aquatic life, but also drinking water. In Des Moines here in Iowa, the water treatment plant there has the largest nitrate removal facility in the world. And then there in Toledo, Ohio, you might recall a few years ago, they had a big algae bloom that made the water unsuitable to drink. So I'll talk a little bit about my work here. This is work we did with a graduate student a couple years ago. We looked at these 23 watersheds in Iowa. looked at water quality data going back to 1999. Then I also aggregated data from these downstream sites, the Missouri River at Herman, Missouri, the upper Mississippi at Thebes, Illinois, and then down at the bottom in Louisiana, St. Francisville and Melville, Louisiana. And so if you don't know, we divert off about 30% of the Mississippi River down here at St. Francisville into what's called the Atchafalaya River. And so about 30% of the Mississippi is actually going down here. And so that's, they do that to keep the Mississippi from changing course. The Mississippi wants to go this way. But of course that would isolate New Orleans and Baton Rouge. And so all the shipping industry down there. And so we have structures on the river down there to prevent that from happening. But long and short, when we look at water quality in the Mississippi River, we have to look at both the Mississippi and the Atchafalaya down there. And so I'm looking at nitrate loading here, nitrate, nitrogen. And this graph shows the Iowa fraction of the nitrate load and the water contributed to the Missouri River. And so you can see on average, Iowa contributes about 60% of the nitrate in the Missouri River at Herman, Missouri. And we contribute about 12% of the water, but we only have 3.3% of the land area in the Missouri River Basin, right? So we have 3.3% of the land, and we're delivering 55% of the nitrate to the Missouri River. Likewise to the upper Mississippi, and so this is the Mississippi essentially upstream from St. Louis, where the confluence of the Missouri and the Mississippi is. We contribute 21% of the water, 45% of the nitrate. We have 21% of the land area. Then down at the Gulf, we contribute 5.9% of the water, 29% of the nitrate, and we have 4.5% of the land. And so this shows if we're going to solve that problem of the dead zone down in the Gulf of Mexico, we're really going to have to focus efforts on places like Iowa. I think I'll skip that. And so the result of this work, we determined that nitrate loads from areas of Iowa going to the Mississippi are increasing about 57,000 tons per year. Iowa areas draining to the Missouri about 38,000 tons per year, and the load down here increasing about 52,000 tons per year. And so when we subtract out Iowa's contribution, the load to the Gulf is actually probably declining. And so again, this emphasizes the importance of trying to get agriculture here in Iowa at a place where it can deliver the environmental outcomes that we need. And so when we look at this 5-year running annual average for end load for the various parts of Iowa, we can see Iowa has about doubled its stream nitrate load since 2003. Areas draining to the Mississippi increase about 74%, and increases draining to the Missouri have increased about 188%. And so what's happening out in Western Iowa, we're not quite sure, but we suspected it might have something to do with livestock. Anyway, all this stuff has been published in this paper here. It's open access. But we got to thinking about the livestock, and especially up here in Northwest Iowa. This map shows hog confinements around Iowa. And so we have a real high density of hog confinements here in Northwest Iowa. And here again along the Mississippi, Missouri Ridge. This is what they call a honey wagon, surface supplying liquid hog manure. And so I looked at water quality data for 1 year here, 2017, for these 9 watersheds draining to the Missouri River. Got some input data, the fertilizer data for commercial fertilizer and for manure, and some animal population numbers from Iowa DNR. And we can see at the 9 watersheds, we've had a real big increase in animal populations in 2 of them. And so that would be the Rock River here and the Floyd, which are the two northwesternmost watersheds. We can see hogs, big expansion of the hog industry up there. Likewise with cattle, there's been a big increase in the number of cattle in northwest Iowa. And lo and behold, those two watersheds have the highest stream nitrate of the 9 watersheds that we studied. And so skip that. And so from the input data, I was able to determine how much nitrogen is being applied to corn. And so the Iowa State University recommended application rate would be about 150 kilogram per hectare for corn following soybeans. And we can see here in the Floyd and Rock, we're way over that, well over 300 kilogram per hectare. And we can see these two watersheds with the highest input rates also have the highest stream nitrate. Likewise, the two with the lowest input rates, East Nishnabotna and West Nottoway, also have the lowest stream nitrate. And so we think that expansion of the livestock industry is playing a strong role here. This scatter plot shows the N surplus down here on the x-axis, and by surplus I mean commercial nitrogen plus the manure nitrogen plus nitrogen fixed by soybeans. And so soybeans are a legume and they pull nitrogen out of the atmosphere and put it in the soil. We have to consider that as an input, and then subtract what's being harvested in the grain. So that's a surplus. And so we can see a real strong correlation between the N surplus and the nitrate concentration. This is a flow weighted average nitrate concentration in the stream. And again, the Rock and the Floyd being way up here. And so the issue here is really that farmers that are applying manure are still applying commercial fertilizer. And so they see the manure as sort of just a bonus, the frosting on the cake, if you will, to try to squeeze out a few more bushels at the end of the day. And so that has consequences for us for our water quality here in Iowa. And so all this manure also contributes to the recreational suitability of our streams. This is the Raccoon and Des Moines River in downtown Des Moines. The E. coli accounts that are in those streams and how they compare to the recreational standard, which is there in the red line. And we can see for most of the warm water season, the Raccoon River especially is not very suitable for recreation because the levels of E. coli. And so this graph, a lot going on here. I recognize the bars represent the various input sources in Iowa. And so the dark green is commercial fertilizer, the orange is hog manure, the red here is beef manure, dairy manure, fixation from soybeans, poultry. And then the yellow bars is how much nitrogen is being removed in the grain. The blue is the river load. And so this red line is the surplus, difference between the harvested nitrogen and the input nitrogen. And so we can see about 32% of the surplus is making it into the streams over the long haul. And so we really could still do a better job of managing our nitrogen inputs. And we really need to do that if we want to improve water quality here in Iowa. And so I'll focus on this table on the right here. Since 1999, river nitrogen increased 83%. And then we can see the different input categories there. And so the grain nitrogen, we have increased yields of crops. And so we're removing more nitrogen in the grain, about 27% more. But that 27% has produced an 83% increase in load in the stream, right? And so this is exactly how we'd expect an ecological system to respond as we try to squeeze every last drop of performance out of it, right? And so we get diminishing returns on our inputs. And then the environmental impacts of that are magnified here in the river. And so I'll finish up here with this map. We have what we call 50, we have 57 what we call Huck 8 watersheds in Iowa. Huck 8 is about 1,000 square miles on average. We have about half the people in Iowa live in 8 of those watersheds, right? And so you can see them there. But when we factor in the livestock, okay, so livestock produces waste, right? And so we know a hog produces a waste of about 4 people, a cow about 14 people. This is the population, the equivalent population of these watersheds. And so, this is waste that all these animals are producing. And so, this is untreated waste that's applied to our fields. And so are we going to be able to achieve the water quality objectives that we want here in Iowa by continuing the status quo here on our system? I would submit that we, will not be able to. And so we really need to look at the system and can we transition it to look like something different if we're have any hope on getting the water quality objectives that we want here in Iowa. And so that's my last slide, and I'm happy to discuss anything you'd like to discuss about this or the water, the science communication stuff, or, feel free to ask whatever you'd like to ask.
Yeah, thank you, Dr. Jones. That last picture, wow. Look at the population, like relative, just it's wild to think about.
Yeah. Thanks so much for the talk. That was super interesting. Yeah, personally, I guess
I
now I
went
know.
pretty fast. I don't generally go that fast, but I thought you guys wanted to discuss some things, so that's why.
Yeah. No, we appreciate that. Obviously, just there's lots of things we do. So I think it seems like on the kind of policy level, it's a lot of don't go as deep, but at least get enough of an idea to be able to talk about it on a more educated level. I would have one question. So when you talk about water quality, it seems like you're mainly measuring nitrates. Are the nitrates themselves, I guess, the issue or the problem with the quality, or are they more of a flag or a data point you easily measure that is indicative of other things like you've talked about E. coli on the river?
So yes, some people do kind of look at nitrate as an indicator for other soluble pollutants that might be there, but nitrate in and of itself is an issue because it's a regulated contaminant for municipal drinking water. And so there's a maximum amount that is allowed in treated drinking water, and that's 10 milligrams per liter as nitrogen. And so we have about 60 public water supplies in the state of Iowa that are defined as impaired for nitrate, and one of them is the University of Iowa system. So the University of Iowa uses, we have our own treatment plant on campus, right there by the bridge on Burlington Street, and that would be on the northeast corner of the bridge. And so it's using Iowa River water directly. The Iowa River can have high nitrate, so they have a reverse osmosis system now to remove nitrate. And so yes, nitrate is an issue in and of itself because of the drinking water component, because it supports or increases the likelihood of these big algae blooms, which in turn reduce biodiversity. But, it's also an indicator that, we're wasting a lot of our input materials and the manure and nutrients in our farming system.
it seems like type of policy that would, like the solution for that would be pretty tricky, right? Because you'd want to say like, oh, use less, but there's the economic aspect where we're doing this because we're trying to get as much product out as we can. And do you know if there's a lot of research going into maybe refining it or looking for an alternative way to boost production of crops or product?
So yes, and we've been aware of this problem since the late 70s, and so agronomists and soil scientists and farmers themselves have experimented with different forms. We have the anhydrous ammonia, we have liquid forms, liquid urea, urea ammonium nitrate. There's some dry fertilizers, and then there's of course manure. And so what they call the 4 R's, the right rate, the right what is it? The right rate, the right form, the right time, and the right placement. And so, but it turns out, the main R that we need to worry about is rate, and that, how much we're putting on. And so the farmers have really been reluctant to sort of embrace these lower rates that have been advocated by the land grant universities. And nitrogen is cheap. That's the bottom line. And so it's cheap insurance. And so they put down more than what they think is optimum, just in case, right? There's a wet season or a lot of rain that causes them to lose some. They don't want to have to go back and put more down. And so they'll put more down in the beginning. And so this has consequences for our streams and lakes. So it's a really tough problem to solve, the nitrogen pollution.
Yeah, Chris, I have a question regarding that. So everything you're talking about here is the foundation of my research as well. I work with Craig Just and Tim Mattis, and actually hopefully maybe with Q Schilling on a future upcoming project. But anyways, my question is, because all the time you hear about the disconnect between like what people want versus what legislators are saying, or the whole we want clean water, or the like there is a disconnect, and there's all of these like solutions or just ideas. Can we just have one of yours? Like, what do you think? Like, because I know like one of your solutions to take on big ag, take on these, like applying manure during the winter, or I don't know, just do you have any, the more I talk about it, the more it's like an uphill battle. Like sometimes I just feel so disheartened. I'm like, there is no solution at all. And so I didn't know how you felt.
Well, there are some low hanging fruit, and one of them is floodplains. We farm about 300,000 acres in Iowa in the 2-year floodplain. And so that makes no sense. We know, 1 out of every 2 years, all those inputs just gone to the Gulf of Mexico. So what can we do to get farmers out of the 2-year floodplain? Nobody is starving here. This whole feed the world thing is sort of a red herring. And so with commodity prices low, it doesn't make sense to farm marginal grounds. And so my first thing would be to try to get some policies that would get farmers out of the floodplains and maybe some of the other marginal land. The second thing would be to try to get a handle on livestock industry. The way that our laws are set up were written 20 years ago now, and the industry has greatly expanded. It's not reasonable to think that we can continue to cram animals into these watersheds and have a good water quality in the stream. We have a mass balance problem with nutrients, and unless farmers respond to the availability of manure by reducing commercial fertilizer, we're going to have problems. And thus far, they haven't been, likely to do that. And so we really need to revisit this permitting system for livestock confinements. And we need to be able to manage nutrients at the watershed scale. Okay. That's the other thing I say really frequently. The other things are fall tillage. Why are we doing it? We know that that enhances loss of nitrogen. Iowa State University College of Agriculture has been putting out guidance documents for 40 years now that fall tillage, especially after soybeans, is a bad environmental practice. Yet we see it all over Iowa. You know, it'd be pretty easy. You know, one law would sort of stop that right away. You know, can we do that? So those are some things that are the low hanging fruit, but you know, ultimately this corn soybean system is going to leak nutrients. We know that. And so why do we have the system that we have? Well, we have it because of government policy. So half the corn in Iowa goes to produce fuel ethanol for vehicles, right? So right there we have a policy that is producing an environmental outcome that we don't like. And so what can we do as far as policy to try to keep farmers prosperous while at the same time getting some better environmental outcomes? And what to me that means is getting more diversity on the landscape. You know, we can't just have two annual crops covering the entire state and expect to have the same environmental outcomes that we had on the prairie, you know, where we had hundreds of species. Now we have two species. And so it just doesn't make sense that we're going to get the things that we want with these two species. We need to diversify the landscape somehow. How do we do that? Well, government policy.
Yeah.
Dr. Jones,
Yeah,
you had mentioned, oh, sorry, go ahead.
No, you go ahead, Cody.
You had mentioned moving farmers out of these locations, these zones. Would you expect farmers to accept something like that, or would you expect more pushbacks? I'm referring more to like the idea of coal mining. Like this is more of a family. Farming is more of a family traditional thing. It's my land. This is where I've been. This is where we've always been. This is what we do. And trying to get them to like, hey, we need to change what you're doing to make this better. Do you think that, would you expect people to accept that generally?
Well, we have a lot of people that want to farm right now, and you know, not a lot of availability of land. And so, you know, like the old saying is, the land God isn't making any more of it. And so what's happened in agriculture is the automation of everything and the concentration of livestock has enabled people to farm to a very old age. And so, you know, not many farmers have livestock anymore. It's all concentrated like hogs. There's only 10% of our farmers have hogs now. And so, you know, we have guys that are farming that are 80 and 85 years old because, you know, with all the technology, the GPS and the tractors that can drive themselves and the climate control stuff and the GMO crops as part of this. It's made this farming for corn and soybeans really easy. And so consequently, young guys can't get in. They can't get the land to farm because, you know, the median age of a farmer now in Iowa, I think, is over 60. And so,
wow,
you know, a guy might be 50 or 60 years old before, you know, the old man dies or finally retires. So consequently, what options do they have? Well, one is to put up a hog barn, right? And that's one of the reasons why we have this confinement of animals. The old man will give them 10 acres and they'll put up a hog barn, or they will try to farm marginal land, like in floodplains or on hill slopes, or, you know, take land out of CRP to farm it. So we have these socioeconomic drivers that are making the cultivation of these marginal lands possible. The other thing is we have publicly supported crop insurance. And so the taxpayer pays about 50% of the cost of insurance premiums for crop insurance. Well, that incentivizes the production of these crops on marginal lands and in marginal areas. And so consequently, you see guys trying to grow corn in the Texas Panhandle or in North Dakota or Kentucky. And that all affects what happens here in Iowa. And so we have government policy that creates all these perversities in the system, and everything now is aligned. You know, the supply chain is aligned with this and has been for a couple decades now. And so escaping from that is going to be really difficult.
Yeah.
Chris, I have a question for you. Have you seen, it's on Netflix, it's a documentary called Kiss the Ground.
It's called what?
Kiss the Ground.
I haven't seen it.
Okay. Okay, that's okay. I actually would recommend it, but I was just curious because it goes over soil health, big ag, chemicals. NRCS is featured in it, so I just didn't know. I thought I'd ask.
Sure, that's no problem. Yeah, I'll take a look at it.
So I have a question. I'd be curious on a policy level, are policymakers generally, I guess, accepting or reasonable to work with? I don't know how much you've done in kind of that sphere. I know from the kind of questionnaires I had helped done, I know you had seen some of the answers. There was definitely a wide range of opinions on this sort of topic.
Well, firstly, I would say it's a mistake to think that these elected people are smart. They're not, for the most part. Of course, you know, they're just reflective of, you know, society, and so you know, they don't like to, I will tell you this, elected people do not like to tackle problems where they see there's a low likelihood of success. And so like here in Iowa, the likelihood of success of, you know, enhancing water quality is low. I mean, let's just face it. And so consequently, what's in it for an elected person? You know, they don't like to lose. They don't like losses. That looks bad. And so the other thing about elected people is they really like to pursue solutions that have been tried before and have been successful. So if they see something has worked in Illinois, then, you know, they're much more likely to embrace it here, for example. And so I think, you know, a lot of people associate this with power in the Republican Party, right? That they're the ones that resist the change. But I can tell you, there's no way we could have gotten to this point without some complicity from both parties. And so there's many, I would say, in the Democratic Party that just don't care about this that much. And so that's why we have the condition that we have. But if you interact with legislators, I would tell you never be intimidated by them. Very likely they're going to know far less than you do. And when you talk to them, you need to, you know, make your point like in 2 minutes, right? Max. It's got to be the elevator talk. Because they're looking at all sorts of things during the course of their day. And if you can't deliver your message in a minute or two, you know, it's not gonna connect.
Dr. Jones, do you think there's a way to take these no win or low win rate scenarios and break them down into smaller, more achievable, like, we didn't solve the water problem, but look, done, like, you can pitch to a politician they can make a claim like, I'm making progressive step forwards to solving this, and look at what I've done. It may be small, but it's still something they can brag about winning.
Well, I mean, that's the incremental. That's what we call this incremental progress. And so, yeah, people like success stories. You know, you look at the NGOs and they like to put out their brochures with projects that have been a success, and they've, you know, engaged a certain number of farmers, and it, you know, this was the outcome. And so people like these incremental successes, but, you know, the thing to recognize here is the public, the taxpayers subsidizing a lot of this to the tune of billions of dollars. And so, you know, how long can we, you know, go on with this incrementalism, you know, in a credible way? And I think one thing we could really look at here is, you know, try to look and see what our best streams are and focus our efforts on those, and try to protect the best of the best. I think there's some merit in that, honestly. I didn't used to think that way, but for a place like Iowa, until we get policy change at the federal level that will help transition the system to something different, I kind of think that's what we should do.
So it looks like we're coming right up on 5 here. So I think it'd be good we can end things here, but Dr. Jones, would you be all right if any of us have questions to shoot you an
Absolutely.
email?
Yep, absolutely.
All right, awesome.
Yep.
And we will try and get this posted up on our YouTube channel and share it to the members. And yeah, again, thanks again for giving the presentation. I know I learned a lot and very interesting.
Oh yeah.
Check out my blog if you haven't, it's all there. So,
Excellent. Well, thanks so much.
okay, very good. Have a good evening.
You too.
You too.